Welcome to Study Loop.
Hello and welcome to this video solution of Numerid. Here we are given that a technician is testing a computer controlled variable speed motor. Right. She attaches a thin disc to the motor shaft with the shaft at the center of the disc. Right. The disc starts from rest, so I take an omega naught that's equal to 0. And sensors attached to the motor shaft measure the angular acceleration az of the shaft as a function of time based on this graph. Right. Uh, Now A is you have to tell how many revolutions has a disk turned in the first 5 seconds. Now this is pretty simple. So here what we have in the first 5 seconds at t equal to 5 seconds alpha z that's equal to 6 radians per second square, right? And we have got the initial acceleration at t equal to 0. The acceleration is it that's equal to 0 2, right? Because it's, if you see, it's passing through the origin. Based on this you can have the equation this alpha y that is equal to at, let's say, right? So this is the equation of this curve, and you have got this is alpha to be 6, a times t is 5, right? So a is having a value of 1.2. So the equation alpha will be equal to 1.2 t is the equation of this angular the equation of the angular acceleration, let's say, for this disk, right? Next you have to calculate omega, or omega will be equal to integral of alpha dt, right? Which is equal to integral of 1.2 t dt, right? And this omega will be equal to 1.2 t square by 2 plus c, right? And it's clearly given that at t equal to 0 omega will be equal to 0, right? Which is omega naught is 0, I have already mentioned, right? That means it starts from rest. Based on this you will be having c to be equal to 0, this c will be equal to 0. So you have got omega that is equal to 1 zero point 0.6 t square, right? And d theta that is equal to integral of, or integral of d theta will be integral of 0 0.6 t square dt, right? And this will be 0 to 5 seconds, right? Or this comes out to be 0 0.5, theta will be 0 0.5 t cube by 3, limit will be 0 to 5, which is equal to 0 0.5 times of 5 cube by 3 radians, right? That's 20.8 radians is the angular displacement, right? You have to take it in revolutions, right? So this is 20.8 over 4, 2 pi radians, right? Revolutions. It is around 3.3 revolutions. Here I think it's here I've just mistakenly written 0 0.5. It will be 0 0.6, right? And this will be 25, and this will be 25. 25 25 by 2 pi, and this is 4 revolutions is the angular displacement after 5 seconds, right? And next you have to calculate the time it will take for rotating per 2 revolutions, right? So theta is given to be 2 revolutions, or we have got 2 times of 2 pi radians, right? and that will be equal to, here from the same equation, 0.6 t cube by 3. So t will be equal to now 3 around 4 seconds, right? I hope this is clear to you, and have a very good rest of the day. Thank you.